going to use the commutative identity and properties of 1 to write equivalent expressions and to simplify. We're just going to do a bunch of examples here. So in the last video, we learned what the commutative and identity properties are. And now we're going to use those in these examples. So write an equivalent expression using a commutative property. And commutative, remember, says that A plus B equals B plus A. So it basically says it doesn't matter what order you add numbers in. You can add them, you can add the A first to the B or B and the A. So for this first one, x plus 5, an equivalent expression would be 5 plus x. And that'll work for any value of x. So if x is 3, it would be 3 plus 5 is the same thing as 5 plus 3. See how that works? You'll get 8 equals 8. So 8 equals 8. Okay, for this expression, but your answer is just going to be this one. Okay, for the next one, we have 2 plus y. Now an equivalent expression is going to be y plus 2. And to see if that's true, just plug in any number for y and you can test it. So let's say y is 6. So it'll be 2 plus 6 is the same thing as 6 plus 2. And if you look, you know that's true because 8 equals 8. So your answer would be y plus 2. Now the last one is going to be the commutative property of multiplication, which says that A times B is the same thing or equivalent to B times A. So we just have different letters here, so we're just going to write y times x, yx. And that's going to be an equivalent expression. And you can test that out too if you plug in 2 different values for the variables. So if x is 2 and y is 3, it'll be 2 times 3 is equivalent to 3 times 2. And you know that's true because 6 equals 6. So yx will be your answer for that one. Okay, now this next one, rs plus q. Now we can do this. This one can actually have a couple different correct answers. We could use the commutative property of addition and leave the multiplication alone. We could just write q equals rs. Or we could also write sr plus q. So this one we're using the commutative property of multiplication. We're just switching the order that we multiplied the r and the s. Or you can do both. You can write q, that's a q, plus sr. So we not only switched up the order that we added them in, but we also switched up the order that we multiplied those 2 variables. And all of those are equivalent expressions. So that one could have 3 different answers. Now this next one, 5 plus RH, again, you can either use the commutative property of addition, multiplication, or both of them. If I just want to use the commutative property of addition, I can write RH, so I'll leave those in the same order, but I'm going to switch up the way that I add them. So it'll be RH plus 5. And this last one can just be BC plus A. So I think you're getting that. That should make sense. Okay, now the next section here. Write an equivalent expression and then use the indicated expression for 1. So now we're using the properties of 1, which said that any number over itself equals 1. So a over a equals 1. And then it's saying use the indicated expression for 1. So it's going to tell us what to use for 1, and we're going to change the fractions. So 1/2, and we're going to use 3 over 3 for 1. And when it says use, it just wants you to multiply. So we'll start with 1/2, and then we're going to multiply by 3 over 3. And when you multiply fractions, you can just multiply the numerators together, so 1 times 3, and then you multiply the denominators, so 2 times 3, and you get 3 over 6. So 3 over 6 is equivalent to 1/2. So 3 over 6 is the same thing as 1/2, or equivalent, or equal. Okay, this next one, 2/3. Okay, and it wants us to use 4 over 4 for 1. So 4/4 for 1. So we're going to take 2/3, and we're going to multiply by 4 over 4. Now notice in this case I'm using a dot for multiplication. The other one I used the regular multiplication signs. Either way. So we just multiply the numerators. So 2 times 4 is 8. And then 3 times 4 is 12. So we're saying that 2/3 is equivalent to 8/12. And this will make sense that those are equal. Because if you have, let's say you have 2/3. So here's a whole, and then let's divide it into 3 pieces. And you have 2/3. So you have 2 of these. So each one is 1/3. So you have 1/3 and 1/3 and 1/3. And you add those up to make the whole. Well, if you have 2/3, and then now it's saying cut each of those thirds into 4 more pieces. So each of the thirds are into 4. So if I draw a line like this, that cuts them into 2. Okay, so now if you notice, we have 1, 2, 3, 4. So each third is now into 4 pieces. So if you add them all up, you have 4 here, 4 here, and 4 here. So that'll equal 12 total, which is what we're saying here. And how many do we have? Well, we still have 2/3, but count how many pieces we cut it up into. 1, 2, 3, 4, 5, 6, 7, 8. So now we have 8 pieces out of a total of 12. So each third is actually 4/12. So we have 4/12 there, 4/12 there, and 4/12 there. And if you add up the ones that are shaded in, you get 8/12, which is our answer. So 2/3 is the same thing as 8/12. So that was just a little lesson on fractions there for you. Thrown in for free.